Okay, Pathways problem 1.60 from your textbook. Again, another one about scientific notation versus standard notation for numbers. Very important skill. Cannot stress that enough. Everybody needs to be good at doing this. It's a four-part problem, A through D, in which they give us a number, and we are to convert that into scientific notation. So from standard notation to this scientific notation with the exponent 10 raised to an exponent. Okay, so the first one, 131,000.0. Okay, 131,000.0. Now, how are we going to convert to scientific notation? Well, the first thing to know about the scientific notation is that when you convert to it, you generally do so such that there's only one number to the left of a decimal point. Only one number, one digit to the left of a decimal point. Here, that's going to be this 1, that most significant digit, okay? So I write 1.31 just to write this part of the number. Now, I'm going to, of course, also multiply that times 10 raised to a power, and I want to figure out what that power is. So how do I do that? Well, the question becomes, how many decimal places do I need to move my decimal point to move it over here? It looks in this case, it's 1, 2, 3, 4, 5. So 5 is going to be the power that I raised 10 to. Now, another thing. Does that 5 need to be positive or should it be negative? How can I tell? If the number is larger than 1, the exponent's positive. If the number that you're trying to convert is less than 1, the exponent will be negative. Okay, so in this case, we're way above 1. So that 1, 2, 3, 4, 5 is going to be a positive number. So I'm going to raise it to 10 to the 5th. Now I'm getting pretty close to my answer, but I'm not completely happy with what I have written down here. Okay? And this is the details, where details of sig figs come in. What if I'd asked you to convert 131,000 to scientific notation? When you did that, you wrote 1.31 times 10 to the 5th. 1, 2, 3, 4, 5, right? That's what you get. I think this would be a perfectly acceptable answer for converting this number. But the problem is that in our problem, we don't have that number, do we? You just look at that and say, well, yeah, we do, Professor Thompson. Well, I'd argue we don't, right? Because of this decimal point and this 0 right here. The fact that we've included that decimal point in this number says that all these digits of precision have been measured. This 0 is to the right of a decimal point and a non-zero number. It's something that has physically been measured. And I think that in the answer for our scientific notation, we should tell the reader that, okay? So what we would really need to do then is add back in those zeros, okay? Because the fact that we've included that decimal point tells me that that's actually been measured. So it's a sig fig thing, okay? But you definitely want to pay attention to that when you're converting numbers from standard notation to scientific notation. All right, next one. B, 0.00047. Again, we're converting to scientific notation. We kind of write the base non-zero numerals out first with only one digit to the left of the decimal point, and then we figure out what power of 10 we need to multiply by to make a conversion work. Okay? Now in this particular case, this number is far less than 1. I've got to move the decimal point the opposite direction. Instead of moving it to the left here, I'm moving it to the right 1, 2, 3, 4 spots. So I'm going to write that one as 4.7 times 10 to the minus 4th. What about this one? 210,006. Start the process the same way when I'm going to scientific notation. I just write out the number times 10 raised to a power. Now notice in this particular case, because my 6 is over here and that's also a significant digit, all these zeros are also significant because they're between two non-zero numbers. So I've written out all of my numbers in my base for the scientific notation, okay? Got to figure out what power to raise it to. Well, it looks like the decimal place is here. Okay, so 1, 2, 3, 4, 5 to the left. And that's going to be a positive 5 because that number is greater than 1. Lastly, down here, 2.1605, only one digit to the left of the decimal point. That's standard for scientific notation. And to make this work, I've had to move that 1, 2, 3 spots. The number is much greater than 1. Of course, it's over 2,000, so it's going to be a positive exponent. This is converting into scientific notation from standard notation.